Hello everyone. So for this video, we're going to solve a problem involving isothermal flash, and this is the question. A stream containing 20 more percent ethanol and 80 more percent isooctane is flushed at temperature 50 degrees Celsius and pressure 35 kilopascal, and it is separated into a vapor product and liquid product. So it asks us to calculate the fraction of feed vaporized and the composition of liquid and vapor product. So here, we are already given some important information to solve this problem, which is the component vapor pressure at temperature 50 degrees Celsius for component 1 is 29.5 kilopascal and for component 2 is 19.5 kilopascal. So the mixture is non-ideal, so it can be represented using the Wilson model of activity coefficient given down here. And some important information for us to use the Wilson model is also already given, which is our A12 and A21. So we've already drawn a block diagram to visualize this question better. So as we can see here, this is the inlet feed. We have 20 more percent ethanol and 80 more percent isooctane, and we have two outlet feed here, outlet stream here, which is vapor and liquid. Okay, so we have already take out some of the important information from the question. So the first question asks us to find the fraction of feed vaporized, which is the mole of vapor divided with the overall mole. So to solve this problem, we need to use this relation where the overall mole times with the overall composition is equals to the liquid mole times with the liquid composition plus with the vapor mole times with vapor composition. So when we substitute and rearranging this relation, we're going to get a Rashford-Rice equation, which is shown here. The summation of the overall composition times with our K ratio minus 1 divided with 1 plus the vapor mole divided with the overall mole times with K ratio minus 1 is equals to 0. So we need to find this V over F here, vapor over overall, where to solve this, we need to find our K here using the Wilson model as stated from the question before. Okay. So this is the Wilson model. I've already rewrite it. So I and J here represent our component, which is component 1 and component 2. So first we're gonna substitute I as 1. So ln gamma 1 here, this the activity coefficient, is equals to negative ln xi is equals to x1 plus with aij a12 xj is x2 plus with a12 divided with x1 plus a12 x2. This is the value for bij here. I just explained it already. Minus with a21 x2 plus a21 x1 times with here is the xj. This is x2. So just substitute the value here. You get from up here. Just substitute it, and we're gonna get our ln gamma 1 is equals to 1.3264. So the exponential of this value is equals to 3.768. We have to do the same thing for our second component, which is isooctane, and we're going to get our activity coefficient for second component is 1.162. So as stated from before, the K ratio here is equals to the activity coefficient times with the vapor pressure divided with total pressure. So the K ratio for component 1 is equals to gamma 1 times with vapor pressure for component 1 divided with total pressure. So here, our activity coefficient for component 1 is 3.768. So substitute the value. Our P1 saturated is 29.5 from here. So divided with our total pressure 35, and we're gonna get our K ratio for component 1 is 3.176. Okay, so we also need to do the second component, which is the same thing, just substitute I with 2, and 1.162 is our activity coefficient for component 2. The pressure saturated is 19.5 divided with 35, so we're going to get our K ratio for component 2 is 0.6474. So this value we need to sub in into our Rashford-Rice equation here. So Z1 times with K1 minus 1, 1 is for the component, divided with 1 plus, this is the fraction of heat vaporized, times with K1 minus 1 plus with for component 2, Z2, K2 minus 1 divided with 1 plus vapor pressure, the fraction of heat vaporized, times with K2 minus 1 is equals to 0. So just sub in the value. This is our unknown, what we need to find. And after rearranging and make this V over F as a subject, we're gonna get our feed of vapor vaporized is equals to 0.1996, approximately 0.2. Okay, so for the second question, it asks us to find the composition for the liquid and vapor product. So we have to use the same relation here, rearrange it, and we're gonna get our Xi is equals to Zi, the overall composition, divided with 1 plus our fraction of vapor vaporized, times our K ratio minus 1. So just the same thing, you substitute the information. So Zi is equals to 0.2 for component 1, divided with 1 plus 0.2 is our fraction of vapor vaporized, as we can get from here before. And substituting the value for K1 is 3.176 minus 1, so we're going to get our X1 is equals to 0.139. Okay, to find our vapor composition here, so we already know that the K ratio is equals to the fraction of vapor divided with the liquid. So rearrange it. So Yi is equals to Ki minus Xi, Ki times Xi, sorry. Ki here and Xi here is equals to 3.176 times with 0.139. So you're gonna get it's Yi here is Y1 here is equals to 0.441. So we use the same thing for component 2 is 0.8 divided with 1 plus 0.2 times with K1 here, K2 here, sorry, is 0.6474 minus 1, which is equals to, so here we get the value for our liquid composition for component 2, which is 0.8607. So for liquid composition, this is our K2 and this is our X2 before, and I'm gonna get a value of 0.557.